Can you hear me now? Can you hear me? I hope you can. I hope you can hear me now. Right. So we are discussing some chemistry. This afternoon. So the chemistry topic that we are on is acids and bases, and we are going to work through a worksheet that we had as we met our fellow students last time. So if you are interested in having Yebo Tutor program running at your school, you can also contact Vuyani. You can contact Vuyani so that he can get in touch with your school, and our professor will organize so that we can have some session with you over a weekend. Right, so we are on acids and bases, and the acids and bases topic falls under this section of your syllabus. So in case you are only starting recently to study, I hope you can tell what we do here. We look for a topic, we study our topic through practicing examination question papers. So we can actually go back to theory. It's normal for us here on Yebo Tutor. So this is the cradle of your acids and bases topic. Acids and bases falls under what? Chemical change. Chemical change for your grade 10, 11. You'll have done other things that are useful in this topic. Then you also have the acids and bases topic inside chemical change. So you've got reaction rate, then you've got chemical equilibrium, and then you have the rest, electrochemical reactions. So we are also going to jump into electrochemical reactions soon after we are done with acids and bases. So for this month, we want to focus on acids and bases and answer as many questions as we can. So how are we going to do that? Same applies. We're going to pick question papers. So instead of me displaying all the question papers, I've just taken all the question papers into one worksheet. So the worksheet will actually indicate where we get the questions, so it's part of the deal. Right, so acids and bases involve the following. So you're looking at reactions between an acid and a base. You're looking at titrations, you're looking at potential hydrogen, pH, and then you're looking at salt hydrolysis. There are certain fundamentals, right? There are certain fundamentals. If you would like us to work through a worksheet together, you can just let us know. Then we'll just give you a worksheet, and then we will actually work out. So you can actually put your name here, and then you can put your details, and you can actually work out this interesting bundle. Right, so there are some key things that I'm just going to regurgitate right now. See if we still remember them, then we'll start working out. Is that okay? Let's hear from you. If that's fine, I think we are good to start. Right, so the first topic, like we said, acid-base reactions. Before we get to that detail, obviously the first thing that we need to discuss are simple examples of acids and bases. So please list examples of acids and bases and let us know which acids and bases you still remember. So we've got some examples here on the screen. So let me just scroll through the screen that we have here. Right, there we go. So these are examples of what? Of acids and bases. Now it's obvious that I'm sure by now you recall that you can categorize acids and what and bases into strong and what and weak acids, strong and weak bases. So those characteristics are something that I hope that you can actually let me give you some homework. Define a strong acid and a strong base. So let's just do this. I just want to create some space. Add a page. There we go. So this is your homework. Item number 1. So these are notes. This is content that you'll have learned in class. So for your homework, your first one is to define a strong acid. Then number 2, define a weak acid. Number 3, what is a strong base? And what is a strong, a weak base? Okay, so make these, go for these definitions. Then item number 5, I want you to classify the acids and bases, in table. Which table? In table, let me just see the table number, table 9.1. Right, so where do we get this table? You can get it from the Siavula textbook. So please, you can download this textbook for free. If you need some assistance with getting the textbook, please write to us, write to Vuyani, so that we can assist you, right, with that textbook. It's a free textbook. It's called a Siavula textbook. So if you go, Siavula. So if you look for this Siavula textbook, there are grade 12, grade 11, grade 10, all I think science subjects. I've seen science subjects, all science subjects. So there's the physics and the chemistry. I'm not sure about the other subjects, so I'll give you as a task. Right, so we're classifying what acids and what and bases in table 9.1 under strong and weak. So in other words, just go to table 9.1. So you go to table 9.1, you can see that these are what? These are acids and they are what? And their formulae. Then you classify these. So take this one and put it under. Is it a strong or a weak acid? How can you find out if it is? You have to first define, right? So when you define these, then you can have an idea of which to categorize. I hope we're happy up to this stage. If you have any questions, the chat is available. Just drop in your question or your contribution. Okay, this is Yebo Tutor, and we are running our chemistry tutorial, and we've just given ourselves some homework under the very first task. The second task is for you to look at acid-base reactions. So in some of the workings that we'll go through today, we'll also look at acid-base reactions. We won't look at titrations today. Please raise questions as we go in case you also need assistance in another area so that we can bring that area to attention. We might look at pH. I'm not sure if there's a question on pH, and then salt hydrolysis. I don't think we've got a question on that. So the titrations and salt hydrolysis, we are not going to go through them today. Right, so what is our first question? Our first question is from this paper. So you can download this paper so that you can see this question. This paper is a 2021 November paper 2. 2021 November paper 2. That's the paper that we are working with. 2021 November paper 2. Okay, so this paper, it has a question that reads as follows. The first question reads as follows. Let me just make it a bit bigger on the screen that's above me here. Right, let's see what's available. There we go. So let's also explode it. Can we do that? No, still not enough. Okay, I just want it to just fit so that you can at least see the most of what's in this question. Right, question number 1. Right, so this question is, it reads as follows. This question reads as follows. Sulfuric acid H2SO4. It ionizes into 2 steps as follows. Sulfuric acid H2SO4. It ionizes into 2 steps as follows. The first step, we have our sulfuric acid. When we are trying to have it ionize, obviously we are just putting it into our water, isn't it? So we put it into our water so that it can dissociate. So it ionizes into the following: HSO4 minus plus the hydronium ion. So that is the way sulfuric acid dissociates in solution. When that has taken place, these species, which are the sulfuric acid species, these species also dissociate. So these species also dissociate. Excuse me. Okay, good. So these species now dissociate. So these are the species that are dissociating. The HSO4 species dissociate in water as well into SO4 and the hydronium ion as well. So this is what is taking place. Then in these two processes, the following parameters are given. We're given the Ka, or the equilibrium constant of the acid dissolution step, and also an equilibrium constant of the radical dissociation step. So the HSO4 ion will also dissociate. Then it will dissociate according to what is seen, and the rate at which it dissociates it is characterized by that Ka, which is the dissociation constant. So that is what is taking place. So as part of homework, right, I want us to discuss these questions next week, right? But as part of your homework, please find out, what is this Ka? What is this Ka, isn't it? I just want to see if we have a tool, that can help us to come up with these chemical reactions, because one of the basic things is check if the chemical reaction is balanced, right? Check if the chemical reaction is balanced. So let's look for a tool. Let's look for a tool that has got some options for us to try and balance a chemical reaction and see if it works. Selected here, unfortunately I cannot change a lot of things, right? So I cannot check with us together. We cannot use it to actually try and balance the chemical reaction. So let's do it together. Okay, let's do it together. So we want to balance the chemical reaction and see if it is balanced. So they've just said 2 steps. They've not said 2 steps according to the following balanced chemical reactions. So it's always important for you to check first. So let's look at chemical reaction number 1. Let's look at chemical reaction number 1. We have an H2SO4. We have H2O, which is the water, and these are our products. So let's first look at the hydrogens. So on we have a left-hand side of the chemical reaction and a right-hand side. We have hydrogen, we have S, and we have oxygen. So let's just assume this is a table that I've created. Number 1, how many hydrogens do we have on the left-hand side? The number of hydrogens on the left-hand side, we have 2 hydrogens, we have another 2 hydrogens. So in other words, we have 4 hydrogens on the left-hand side. Let's look at the sulfur atoms. The sulfurs, we have a sulfur on the left-hand side, which is just 1. So one sulfur. And then the oxygens on the left-hand side, we have 4 oxygens, and we have another 1 oxygen here. So we actually have 5 oxygens on the left-hand side. So what did we do? We just looked for the hydrogens, isn't it? 2 hydrogens, another 2 hydrogens makes 4 hydrogens. Happy for the left-hand side? Yes. Sulfur, we have 1 sulfur, no other sulfur. So we are happy to see that we have 1 sulfur. How about the oxygens? We have 4 oxygens and another oxygen here. So we actually have 5 oxygens. Remember, our coefficients, stoichiometric coefficients here are just 1 and 1. So these are what we have on the left-hand side. Let's now look on the right-hand side. This is still equation number 1, or process number 1, by the way. Right. So if you have a question, you're free to just drop in your question onto the chat. So the left-hand side has 4, right, hydrogens. Let's look at the right-hand side. We have 1 hydrogen here and 3 hydrogens. So we have 4 hydrogens. So we're happy that we are balanced as far as the hydrogens are concerned. Let's look at the sulfurs. On the right hand side, we have one sulfur, no sulfurs. So one sulfur here, and we have one sulfur here. So the sulfurs are balanced. Next, we're looking at the oxygens. We have 4 oxygens here and 1 oxygen there. So we have 5 oxygens on the right hand side, 4 plus 1, which is the same as the 5 here. So our equation number 1 is balanced. Would you like to try? Would you like to try? I'll give you the challenge to balance chemical reaction number 2. So let me give you as another piece of homework. Let me also arrange my pages here so that I don't keep flipping too much. So what am I looking for? I'm looking for our homework page. I want to take it closer to our work. So homework number 6, right? Homework number 6. Check if equation number 2, so let me write it as equation or process number 2. Process number 2 is balanced. Check if equation number 2 or process number 2 is balanced. That is this one. So I'll work with it as if it's balanced, isn't it? I'll work with it, then I'll hear from you if it is balanced. So I'll delete this so that we can start some work. So the first question reads as follows. If you have a question on the basic processes of balancing the chemical reactions and so forth, that is your chance for us to discuss. So the very first question that we will look at is this question, and it reads as follows. Question 7.1.1. That's our first one. It says, define an acid in terms of the Lowry-Bronsted theory. Define an acid in terms of the Lowry-Bronsted theory. Now, there are 2 theories that define acids and bases, right? So, what is an acid according to the Lowry-Bronsted theory? So, let's just look at those 2 definitions. So, I think I've given you enough homework. 6 pieces of homework, that's too much. So, let's now look at the theory. So, this was our first part. I'll just call it part A of the work. Part B now, we just want to revise something. So, definitions of acids. Right. So you can also look at definitions of acids and bases, right? But I will look at acids so that we can answer the question. So we have 2 definitions of acids and bases. You can define acids and bases according to these 2 scientists, right? Arrhenius theorem or the Bronsted-Lowry theorem. Bronsted-Lowry theorem. So these are the 2 theories that you can use. So what does Arrhenius state? What does the Arrhenius definition state? Because what we know is that the Bronsted-Lowry theory states that an acid, so it defines an acid as a proton donor. An acid is a proton donor. How about Arrhenius theory? I'm tempted to give you 1 piece of homework. All right, no more homework. So Arrhenius theory simply defines an acid as a substance, a chemical substance that increases the concentration. It increases the concentration of what? Of hydronium ions in solution. So if you were to take an acid and dissolve it in water, right? So it has dissociated. It is a substance that will increase the concentration of hydronium ions. So the Arrhenius definition is based on the dissolution of the acid into what? Into water. Okay. So basically that is it. So this is your definition. It is simply a proton donor. So this is your result here. An acid is a proton donor. An acid is a proton donor. Right, so let's just see if there's something that can actually show us these protons. Let's just see. I'm just curious, right? I'm just curious. Right, so we have an exciting tool from the University of Colorado which shows us a way of trying to understand these acids and bases. So this tool is found on the following link. Let me just share it with you first. If you are using your computer to study, or you are just doing some online learning, maybe during COVID, restrictions, you had to learn online. So you can just try this acid base tool, right? So I'm just putting this onto the chat. Try this acid base tool. So I've just put in a link there. So if you go into the chat, you can just click the link. Then you can find an acid-base tool that you can try. Right, so that's the tool that I'm going to use. So first of all, what does the tool do? So it basically we have some pH measurement instrument here. So it's very exciting that you can actually just click it and then it will show you the pH. Right, so you can try that out. Right, next is after the pH is measuring instrument. By the way, we will discuss pH, but if you have a question on pH, you can immediately drop it into the chat. So in solution, it has some solutions, right? It has some solutions. So we'll say that in this solution, what do we have? So you can select, we have water, H2O, or we have a strong acid, which is HA, and then you've got a weak acid, which is HA as well. You've got a strong base, metal with a hydroxide, and then a weak base, just a B. Right, so I'm sure for your acid you already know that it will be a proton donor, isn't it? So it has to have some hydrogen somewhere in it, and then you've got some weak acid, which is also it weakly dissociates. So there are certain things that we are going to see in this magnifying glass. So this is a magnifying glass. The whole idea is we can't see molecules, so this magnifying glass is just showing us the molecules. So this reaction is the reaction that is used for the Arrhenius definition of acids and bases. So according to the Arrhenius definition, what we're just seeing here, we're just seeing some acid dissolving in water so that we can get to see some hydronium ions and some ion that is negatively charged. So that is, if it were, let's say, HCl, then you'd have what? Some Cl minus. So this is the an ion that is dissolving. So according to the color scheme, there's a color scheme that is given here. The color scheme has the acid as the gray, so it has the hydrogen atom, tiny gray, and then it has the bigger atom here, which is the anion. Then it has the water molecule. We can see it with its typical color, typical shape, right? Typical shape for the water molecule. Then we also have the anion as the big blue anion, and then we've got the hydronium ions. Right, so this you can actually, by just looking at this tool, you can actually have some hints on the answers to the questions that I gave you. You can actually find some hints on the answers to the questions that I gave you. So what I'm trying to do here, we're just looking at acids as proton donors. So in this case now, if we look at our water, Our water is it is made up of the following. And this chemical reaction here, you should also try and find out what is it called. Right? It's a special type of chemical reaction which spontaneously takes place in water at an equilibrium constant probability of approximately 1 times 10 to the power minus 14, right? So this is an autoprotonation of water, autodissociation of water. So you've got two water molecules here, right? You can see them with their whiskers, right? So this is the oxygen, these are the two hydrogens. These water molecules, they spontaneously dissociate. So you've got the hydronium ion, and then you also have the OH minus ion. So this is what we have. So if we are to take our pH measurement instrument, okay, so maybe let me not take it for now, but we just want to see what will happen. So if you have a strong acid, this is what takes place. The strong acid it's a proton donor, isn't it? So can you see how many of these hydronium ions we have? Can you see how many hydronium ions we have? We have a lot of hydronium ions. And it's because of the dissociation of water, and therefore we've got a donation of lots and lots of these hydronium ions. So that is a what? That is a strong acid. Strong acid. Most of its molecules have already dissociated into what? Into the hydronium ion and the anion. So there's just blue and orange here. So it's just the hydronium ion and the anion. Now the next one is a weak acid. Look at the weak acid. A weak acid, what do we expect? It's supposed to partially dissociate, isn't it? So if we were to click here, look, these are the acid molecules. So this is the HA, right? The hydrogen and the anion to form an acid. Then you've got the water, which is the usual, slightly different color. Then here we've got the anion and the hydronium. So if it were a strong acid, we would have this all shaded in what? In blue and orange. But look, we still have some of the acid ions. Can you see? We still have some of the acid ions. So in fact, we still have most of the acid ions and very few of the anion and the hydronium. That's what a weak acid partially dissociates, right? So another piece of useful information is that you can also use something called litmus paper. We will discuss about litmus paper later on, but otherwise, as far as the definition is concerned, we already have some idea, isn't it? So we've already seen some tool that can actually help us to identify what's happening with this acid. So it is a proton donor. In other words, if we were to put it into solution, it will donate H ions, H plus ions. Now, there is a second part, 7.1.2, question 7.1.2. What does it say? So we've already written the answer for this. I hope that you can now do all that homework that is attached to this question. The second question reads as follows. Write down the name, right? So the name or the formula. So this is an option that we have. The name or the formula of the substance that acts as an ampholyte in the above equations. The substance that acts as the ampholyte in the above equations. So I'll just go back to the above equations. I'll just keep the question here, right? And then let's go back to the above equations. So the first question is, what is an ampholyte? So let's just look at this and see if we can discuss an ampholyte. What is an ampholyte? In other words, what is an amphoteric substance? What is an ampholyte? Part C, we're discussing some ampholytes. Ampholytes. What is an ampholyte? What is an ampholyte? So, that's the first thing. When you go through that definition of the ampholyte, it will tell you that an ampholyte or an amphoteric substance is just a substance which participates in chemical reactions as a base in one chemical reaction and then as an acid in another chemical reaction. In other words, in one chemical reaction, it donates protons like an acid. In another chemical reaction, which is different from the first one, it accepts protons like a base. So, in what we are going to discuss, all we are looking for is a substance. This is a substance that participates, so it participates in a chemical reaction, in two chemical reactions, as a base, and then an acid separately. So it participates as a base in one chemical reaction and it participates as an acid in a second chemical reaction. So let me give you a chance to look for the ampholyte. So this is the question now. Let's look for the ampholyte in this chemical, in these two chemical reactions. Let's look for the ampholyte. Right, let's relax while we wait for you to look for the ampholyte. what have we done now? Have we found the ampholyte? How do you approach this question? Or how can you fetch for the ampholyte? One way of trying to find the ampholyte would be look at one species and then trace what's taking place to that species in its participation in the chemical reaction. Right. So let's look at the first species, which is the HSO4 species. Let's look at the first species, which are the HSO4 species. Right, the HSO4 species is the species that has the SO4 group, isn't it? So it is obvious that in the forward chemical reaction, right, this is where this topic comes in. In the forward chemical reaction, this H2SO4 species dissociate to HSO4 species. So we can tell that for the H2SO4 species to dissociate to HSO4 species, then we should have lost one hydrogen ion. We must have lost one hydrogen ion, right? Can you see that chemical reaction? It has already told us or shown us that in the forward chemical reaction, this is the donor. In the forward chemical reaction, this is the donor. Remember, this is an acid that is put in water. This is an acid that is put in water. It dissociates, right? But there is an equilibrium constant that shows us, in this case, that it is larger than 1. It is a very large number. So it shows us that the forward chemical reaction is favored. So in the forward reaction, then HSO4 is a donor. Let's look for HSO4 in the second chemical reaction, isn't it? In the second chemical reaction. So we can start by looking at the second chemical reaction as the reverse of this chemical reaction. We do not have HSO4 in the reverse. So HSO4 will not work for the reverse analysis. Let's look at the second chemical reaction, which is this one. In the forward direction, we do not have any H2SO4, neither do we have any H2SO4. So it is obvious that the H2SO4 species are out. This does not qualify to be an ampholyte. Why? Because it is only participating in one of the chemical reactions that we have been given. Remember, an ampholyte is conditional. It is an ampholyte on the grounds that it is participating in the chemical reaction in the two different chemical reactions that you have been given, not necessarily in any two chemical reactions that you have been given. Right, so in this case, the sulfuric acid is not an ampholyte. Let's look at the next species, water. Water appears in two chemical reactions, this chemical reaction and that chemical reaction. For water, we are only going to consider the forward chemical reaction, isn't it? Just because it is a reactant in the forward chemical reaction. So we are obviously going to look at the forward chemical reactions. So let me just make these arrows to be looking a bit neater. Right, so this is our forward direction of the chemical reactions. So the next thing is, now let's look at water in the first chemical reaction. Let's look at water in the first chemical reaction. Let me just remove all this. So this is what happens to our water. Our water, it has the H2O group, and the other species on the right hand side that obviously includes the water, H2O, is the H3O ion. So water becomes H3O plus. And what would have happened? It's obvious that there has to be an additional hydrogen ion. That additional hydrogen that has been added to water is what results in you getting an H3O plus. This is where the plus is actually coming from. That's your H3O plus. Right, so we are happy. We now know that, okay, in the forward chemical reaction, or in the first chemical reaction, water is actually participating as a proton acceptor. So it is a proton acceptor in the first chemical reaction. So we're happy. Next, we now look at water in the second chemical reaction. If it is now a donor, it is now the ampholyte. So please tell us what's happening in the second chemical reaction. So you can actually write what's taking place. As you can see, water is H2O, so it looks exactly like what we had here, and it is participating in the forward chemical reaction as a reactant. Then on the right hand side, obviously the species that include H2O are the hydronium species, and this is exactly the same as what took place in the first chemical reaction. This is exactly the same process. Water is also accepting, right? It's also an acceptor in the second chemical reaction. In the first chemical reaction, it is an acceptor. In the second chemical reaction, it is an acceptor. So therefore, water in this set of two chemical reactions is not the ampholyte. Okay. So next, what's next? We now look at HSO4, right? First of all, can we see HSO4 in both chemical reactions? Yep, we can see HSO4 minus here and there. So it's a candidate. So let's look at HSO4 in the first chemical reaction. In the first chemical reaction, what we can tell that HSO4 for the forward reaction, it is a what? It is a product. So therefore, we can only investigate HSO4 in the reverse reaction. So I'll put this now at the bottom here and try to make it look like the proper equilibrium symbol. Right, so this is what we are seeing here. We're just saying that in the reverse in the reverse process, since this is a what? An equilibrium chemical reaction. In the reverse process, HSO4 is participating as a reactant. So what is the chemical process that is taking place as far as this reverse process is concerned? First of all, we can tell that HSO4 minus is actually becoming. This is the only species that have the SO4 group. So it is becoming H2SO4. Now, what could have happened for HSO4 to earn another H? So there must be some additional hydrogen ion. When it receives an additional hydrogen ion, it becomes sulfuric acid, right? So the ions are now balanced, and we can tell that, okay, in the reverse reaction, HSO4 must be a what? It must be an acceptor. It is an acceptor. It is accepting this hydrogen ion to form sulfuric acid. So that's what we have seen. It is an acceptor. Now, may you please tell me, when you are looking at this chemical reaction, can you see something that relates to this word? Can you see something that relates to this word? I'm tempted. Please go and read and try and explain which is the conjugate acid, which is the conjugate base. Please look at what is taking place in these two chemical reactions. These chemical reactions are loaded with a lot of theory, right? So you can actually find you can actually define a conjugate acid and a conjugate base. Then you can actually identify which is which in these two reactions. We are done with the first chemical reaction. Let's now look at HSO4 in the second chemical reaction. In the second chemical reaction, HSO4 is on our left-hand side, so it is a reactant in the forward direction. What is taking place to HSO4 in the second chemical reaction is the following. HSO4 changes to, obviously, it is the one which owns, or it holds the SO4 group. So it actually becomes SO42 minus. What could have happened? What could have happened for HSO4 to end up as SO4 only? It's obvious that there was a subtraction of a what? Of a hydrogen ion. So it's obvious that we have it here as a subtraction of a hydrogen ion. So what has it done? It has actually donated this hydrogen ion into solution. It is actually donated into solution. Which species received the hydrogen ion? It's obvious. It's the water which became the hydronium ion. So therefore, in the second chemical reaction, HSO4 is actually a what? A donor in the second chemical reaction. So from this exercise, we can already see that we have this as a donor and we have this as an acceptor. So HSO4 is the first candidate ampholyte substance in our chemical reactions. Any questions on that? Now, can I give you some work to do? The work to do is figure out the only other species that could be a candidate for being an ampholyte. In other words, species that appear in both chemical reactions. Right now, we can immediately take SO4 out because it is not appearing in both chemical reactions. As a standalone species, SO4 2-, we only see SO4 2- ions in the second chemical reaction. So it's the same as what we saw with H2SO4. So this can certainly not be our ampholyte. So you now look at H3O, the hydronium ion. It appears in both chemical reactions. Now ask yourself, is it a donor or an acceptor in these two chemical reactions? So in this part of the exercise, we can now say we have found the ampholyte. We have found the ampholyte. So which is the ampholyte in this chemical reaction? HSO4 minus is the ampholyte. HSO4 minus is the ampholyte in this chemical reaction. Right, so we've covered a lot of things. So what I will ask you to do now, there's an exercise that I already gave you which will actually help you to answer this question. Let me just scroll down to the question that I want to leave you to do. I want you to participate in this question. Then next week when we discuss, I want you to tell me the answer and how you came up with it. You can also drop the answer into our chat, isn't it? We've got some chat. So make sure that on the WhatsApp chat, you can then just tell us the answer. Alternatively, you can just attend to this tutorial, then we can discuss your answer. Okay, so the question reads as follows. The conductivity of solutions of HSO4 aqueous and H2SO4 are compared, right? Which solution will have a lower conductivity? So the conductivity of solutions of HSO4 minus and H2SO4 are compared. Which solution will have a lower conductivity? Right. So obvious here, the first thing is you need to find out what is conductivity and how does conductivity depend on the presence or the absence of ions or these solutions. So this is the question that you need to ask yourself. How does conductivity of a solution depend on the type of species in a solution? Let's say the type of species, or let's just say species. On species or molecules or ions, so I'll just leave it at species, right? Because species will cover everything. In solution or in a solution. So ask yourself, so which means you're looking at conductivity. That's your topic. So you go and look at these two solutions. So these are the solutions that they're talking about, right? So they are saying the conductivity of solutions of HSO4. So this one is a solution of HSO4 because it has this HSO4. And H2SO4. So this one is also a solution of HSO4. In other words, we're just looking at both these chemical reactions. Solutions of HSO4 and H2SO4 are compared. So we've got this solution of H2SO4, this solution of HSO4. Which solution will have a lower conductivity? So when you look at these, please look at, number one, the constituents that are in these chemical reactions. Number two, look at the chemical equilibrium constants. Compare the two chemical equilibrium constants and deduce from those chemical equilibrium constants what could be the dominant chemical reaction in these reactions. Is it the forward chemical reaction or the reverse chemical reaction? So you can actually deduce that from here. When you have that information, you can then tell the number of ions that you can find in solutions. Okay, let me keep quiet because I might spill the answer out. Okay, so let me just hear from you. If you have any questions within the next 1 or 2 minutes, drop the questions right now. If you have any questions within the next 1 or 2 minutes, drop the questions onto our chat right now so that we can discuss what has been happening in this tutorial. Drop your questions while I wait. So it's time for a summary. It's time for a lesson summary, right? So what have we been doing? What were we busy doing today? Right, this is a summary. So we had some introduction to acids and bases. When we had some introduction to acids and bases, we discussed that these are important things to look for. So I gave you some homework. What is a strong acid? What is a weak acid? What is a strong base? What is a weak base? If you would like to see that pictorially, if you would like to see that in an image, right, so that you can maybe remember, you can actually try and use this tool. So I gave you this link so that you can try this tool. So this tool is a very exciting software tool. It's found, you can just jump onto the site. I think I put a link there. Good, yeah, it's still there. Okay, so this is what you will do. You will try to investigate what a strong acid is by first of all looking at the solution. This is the solution. It has 1 liter of water, right? So within the water, there is some spontaneous dissociation of the water molecules. So we can now see that, okay, the water molecules are of this color, the hydronium ions are of this color, the hydroxide ions are of this color. Then we'll then put some acid into this solution. So when you put an acid into this solution, it will dissociate, right? It will dissociate. The extent to which it dissociates is actually determined by its strength, right? Its strength will determine its dissociation extent or degree or percentage, if you would like to put it that way. So you can actually play with this tool. So that was our first piece of homework. So we can say in summary, the first topic that we looked at are strong and weak acids and bases. So we already have the tools as far as what to do is concerned. What is the second thing that we covered? The second thing that we covered are definitions of acids and bases. So we just looked at acids, so which means your task is to extend, isn't it? You do this in class, so make sure you write down some of these things so that you remember the definitions. So we looked at what? Definitions of acids and bases. We looked at acids today, but your homework is to what? Is to also find a definition for a base. That was the second thing. Right, what was the third thing that we covered? We covered ampholites. So we looked at an amphoteric substances. What is an amphoteric substance? We looked at that. Water is also amphoteric. Can you see that? Water is also amphoteric. In one chemical reaction, it can act as a base. In another, it can act as an acid. So it's a common amphoteric substance. Right. Remember, its acting as a base is amphoteric. It depends with the chemical reaction that is actually taking place. So we cannot right away say water is an acid or water is a base because it decides, right? So that's a very exciting feature. So amphoteric substances. Then number 4, what did we look at? That was all. Okay. We also looked at some chemical reactions. I think we also talked about balancing chemical reactions. Balancing chemical reactions. Right, we also looked at that. So it's balancing chemical reactions is a must. Every time you meet a chemical reaction, before you even go ahead, check and see if it is balanced and balance it, right, if you need to. Okay, so I think now we have seen that, okay, this is how acids participate, and we've identified an amphoteric substance. I can even maybe ask you to look for amphiprotic substances, right? And see if you can define that and identify some of those substances. Otherwise, this covers what we had for you today, indeed, in the chemical, not a chemical equilibrium, acids and bases tutorial. So your next set of homework or your next task. Where were we? We were here. Right. So your first piece of homework is 7.1.3. We'll take it up from next Friday. Then, can you see something? By the time we finish this month, right, you'll have revised a lot of acids and bases questions. You hopefully be aware of all the corners, isn't it? Because we want to make sure that we actually go through the theory that is actually the examinable theory. Then the next thing is you are going to look at the pH. So this is going to be very exciting because we are going to play around with this pH meter. Where is the pH meter? There's the pH meter. So I'll use the pH meter first. And we said we can take this pH meter and dip it into the substance. When we dip it into the substance, it gives us the pH value. Okay, so it gives us a pH of 7, but what does it mean? What does it represent? So go and read about that. When we take a strong acid, it's going to give us some pH, right? So next week we'll be dipping it in so that we see what happens when we have a strong acid. What about when we have a weak acid? And then the same takes place for the bases. So this is the end of our tutorial. Thank you very much for your attendance if you were watching, or for your watching if you attended later and you looked at the video later. We are going through acids and bases in the month of May. The hopeful case is we need to finish all our questions by the end of the month. We have questions from 2021 paper. We're also going to go to questions from other papers. 2020 paper, right? We're also going to work out questions from the 2020 paper for grade 12. Then we'll also go to, this is the 2020. We will also go to the 2019 paper. So we've got 3 papers that are very recent that have questions that are relevant. Thank you very much. Enjoy your day. Have fun.